Auzubillahiminash-shaytanir-rajim. Bismillahir-rahmanir-rahim. Assalamu alaikum, dear students. In our previous lecture, we discussed about the introduction to geotechnical engineering, history of geotechnical engineering. We also highlighted the importance of geotechnical engineering in various civil engineering projects, and we showed you videos, case studies where we highlighted the importance of geotechnical engineering, and if we avoid or ignore the understanding of geotechnical engineering, significant time losses and financial losses could occur. Now in today's lecture number 2, we are going to learn about soil and its constituents. We also going to discuss the types of rocks and the types of weathering and types of soil. So first we are going to start with the understanding of origin of soil, that how the soil particles are formed, what is rock, how geologists think or what they are looking for, and what geotechnical engineer is interested or what properties they are interested in. Types of rock, for example, igneous, sedimentary, metamorphic. Types of weathering, whether the rock has been weathered or disintegrated using mechanically or using chemical weathering. What is soil mass? Then we are going to discuss different types of soil based upon the moisture content, based upon the mode of transportation and deposition, on the basis of texture or appearance, based upon the particle sizes. What is soil fabric? What are the clay minerals, for example, elite, kaolinite, montmorillonite, and how they affect the engineering properties of soil or clays. We will also understand and discuss about the interparticle forces, that what gives the strength to the soil particles, whether it's weight or whether it's interparticle forces, cohesive forces, or the weight of the particle. At the end of today's lecture, we will discuss about the water content and how we can determine the water content in a particular soil sample. So starting with the origin of soil, we discussed and we defined the term soil in civil engineering is defined as the uncemented aggregate of mineral grains and decayed organic matter. So if you are having mineral grains and decayed organic matter with liquid and gas in the empty spaces, and we name the empty spaces voids, and these voids basically equals to the volume of water and volume of air. Generally, soils are formed due to weathering or disintegration of the rocks. Thus, the mineral grains that form the solid phase of a soil aggregate are the product of rock weathering. So we can simply say that the engineering properties or the physical properties of soil are dictated primarily by the minerals that constitute the soil particle and the rock from which it is derived, whether these particles are obtained from the igneous rock, metamorphic rock, or sedimentary rock. That will determine the shear strength, compressibility, and the hydraulic connectivity of that particular soil. Many of the physical properties of the soil are dictated by the size of the particle, shape of the particle, whether particles are clay sized particles, whether these particles are sand size, whether these particles are gravel size, cobble size, boulder size. So these all particle sizes are the shape. For example, we are going for the rounded particles, if we are having angular particles, if we are flat particles, elongated particles. These all particles leads to certain type of engineering properties. Chemical composition, for example, the mineralogy, different types of minerals are present there. For example, feldspar, in clays, elite, kaolinite, montmorillonite, carbonates, and other minerals also leads to different types of engineering properties. Now, to better understand these factors, or one must be familiar with the basic types of the rock that forms the earth crust. Now, what is a rock? Geologists think that it's an aggregate or mass composed of one or more minerals, while engineers or contractor define rock to be hard, durable material that can't be excavated without blasting. Because when you are building a structure, when you are constructing an embankment, or if we are cutting a rock and dealing with slope stability issues, blasting will cost the time as well, and also it will require finances as well. So therefore, understanding the different types of rock is also important. So on the basis of mode of origin, rocks can be divided into the following three types: igneous rock, sedimentary rock, metamorphic rock. These are the three different types. Now, igneous rocks are formed by the solidification and cooling of molten magma or lava. Now, what is solidification? Solidification is the process when a molten liquid becomes a solid. Magma or lava is a viscous solution of silicates and non-silicates. Minerals, rock in liquid form inside the earth crust mantle is called magma, but when it comes to the surface, it's known as lava. So that's inside the earth surface, magma. Outside, or when it comes to the earth surface, it is known as lava. You can clearly see here the magma is inside the earth surface, and lava, that's what we see when it comes to the surface. The types of igneous rock formed depend upon the composition of the magma, what kind of minerals are present there, rate of cooling of molten magma, mode of occurrence. Now, based on mode of occurrence, igneous rocks are divided into intrusive igneous rocks or extrusive igneous rocks. Intrusive igneous rocks crystallize below the earth's surface. Below the earth's surface, slow cooling allows crystals to form. Examples are diorite, gabbro, granite, pegmatite, and peridotite. And if you are talking about the texture or the appearance, granite look like this one. Extrusive igneous rocks, molten magma erupt onto the earth's surface, cool quickly to form small crystals. Some cool so quickly that they form an amorphous or formless, shapeless glass. Andesite, basalt, obsidian, pumice, these are the examples of extrusive igneous rocks. And if you're talking about the general appearance of the basalt, so you can see that these are the intrusive and extrusive igneous rocks. Now we are going to talk about the sedimentary rocks, and these are the rocks formed from particles of sand, shells, pebbles, and other fragments of material. Together, all these particles are called sediment, and gradually these sediment accumulates in layers and over a long period of time hardens into rock. Generally, sedimentary rock is fairly soft and may break apart or crumble easily. You can often see sand, pebbles or stones in the rock, and it is usually the only type that contains fossils. Examples of this type include conglomerate and limestone. So here you can see the appearance of the sedimentary rock. Metamorphic rocks are formed under the surface of the earth from the metamorphosis process. The rocks that result from these processes often have ribbon-like layers and may have shiny crystals formed by minerals growing slowly over time on their surface. Examples of this rock type include slate, quartzite, gneiss, phyllite, and marble. Now, what is metamorphism? Metamorphism is the process of changing the composition and texture of rocks by heat and pressure, but without melting. This is an example of metamorphic rock. Now, this slide shows a rock cycle. For example, magma is there beneath the surface of the earth, and crystallization occurs, and it will form the igneous rock. And igneous rock can be intrusive and extrusive based upon the solidification which is occurring beneath the surface of the earth or on the surface of the earth. Then weathering, erosion or deposition, whether it's chemical weathering, whether it's physical weathering, these igneous rocks are disintegrated, weathered into sediments, and the sediments will be compacted and cementation will occur. It will form sedimentary rock. And if heat and pressure is applied, this will transform the sedimentary rock into metamorphic rock, and after melting of the metamorphic rock, magma is formed. If igneous rock is melted, it can become magma, and if heat and pressure is applied, it can transform into metamorphic rock, and that metamorphic rock can again melt and it can come into form of the magma. And this is a cycle which continues over the decades, centuries. Magma is formed, igneous rock is formed, sediments are formed, sedimentary rock is formed, metamorphic rock is formed, and magma is formed. So this is a rock cycle which is a continuous process. Now, what is weathering? The destructive process of breaking down of rocks by mechanical, physically and chemical process into smaller pieces to form soil particle is known as weathering. We can divide weathering into mechanical or physical weathering, or we can say chemical weathering. So these types of stones you will see, or the structure you will see, which occur due to the weathering of a particular rock. Mechanical or physical weathering. Mechanical weathering break rocks into smaller pieces without changing their composition. Composition is not changed. The resultant soil particles retain the same properties as that of the parent rock, because that weathering is occurring mechanically or physically. No chemical composition change will be occurring when mechanical or physical weathering is occurring. For example, expansion and contraction of rocks by continuous gain and loss of heat is occurring, due to which cracks are produced. Water will seep into the pores and existing cracks in the rocks. When the temperature drops, the water freezes and expands, and on expansion, the pressure exerted by ice on rock will disintegrate that parent rock. This picture shows the process which is explained in the above paragraph, that rock with the crack which occur due to the gain and loss of heat. Water enters, cracks freezes and expands the crack, and the cracks even more water enters into and it freezes. Repeated freezing and thawing breaks up the rock along the jointed lines, and you will see the disintegration of the parent rock. Now, other physical agents are glacier, ice, wind, the running water of streams and rivers. Now, particles of this type are indicated by terms such as angular, rounded, flat, and elongated. Now, these particles, for example, angular, rounded, flat, elongated particles will be having different strength, different compressibility, and different hydraulic conductivity. So the particles occur in a wide range of sizes. Different sizes of particles will be having different strength, different compressibility, and different hydraulic conductivity. Now, from boulders down to the fine rock floor formed by the grinding action of the glaciers. So mechanically, there are different size ranges you will see, and these size ranges will definitely affect the engineering properties of the soil. Now, the structural arrangement of bulky particles is described as a single grain, each particle being in direct contact with adjoining particles without there being any bond between them. The state of the particles can be described as dense, medium dense, or loose. Again, if you want to compare the strength of a dense soil particle, medium dense soil particles, or the loose soil particles, the strength will be different, compressibility will be different, and also the hydraulic conductivity will be different. On how they are packed together affect the engineering properties of the soil. Here, if you want to visualize the single grain structure, no bonding is present there, and you will find out a wide range of particles there. Another example of mechanical weathering, you can clearly see that the gap is there, crack propagated, and the disintegration of this particular rock has already occurred. In chemical weathering, the type of weathering in which original rock minerals are transformed. So it's an important point. Original rock minerals are transformed into new minerals by the chemical reaction. Water and carbon dioxide from the atmosphere form carbonic acid, which reacts with the existing rock minerals to form new minerals and soluble salts. Chemical weathering results in the formation of groups of crystalline particles of colloidal sizes, which are less than 0.002 millimeter, and they are known as clay minerals, clay size minerals sometimes. For example, the clay mineral kaolinite is formed by the breaking down of feldspar or by the action of water and carbon dioxide. Chemical weathering, if it occurs, the texture or the appearance of the rocks would be somewhat like these. Now, we understood the origin, the types of rocks, we talked about the weathering. Now, once the weathering has occurred, we will get the weight of solids or the volume of solids. Now, in soil, we already know that's a three-phase system. and solid particles are present there. Water is present there and air is present there in a three-phase system. So we are now focusing on the soil mass, that we are having solid particles, water particles and air in it, and that is known as soil mass. Now if you want to classify different types of soil based upon the moisture content, this is a real soil sample, and in a three-phase system this is a partially saturated soil. In a fully saturated soil, the voids are filled with water, so it's a fully saturated soil. And in case of dry soil, no water particles are present there, so only air and solids are present there. So we can say that there are three types of soil based upon the moisture content. For example, dry soil, saturated soil, partially saturated soil, and sometimes they call that unsaturated soil as well. In another picture, if you want to visualize the saturated soil condition, completely the voids are filled with water. In dry soils, filled with air, and in unsaturated soils, you can see some voids are having air present in there. On the basis of mode of transportation and deposition, soil are of the following types. For example, glacial soils, they are formed by the transportation and deposition of glaciers. Alluvial soils transported by running water and deposited along the streams. Lacustrine soils formed by the deposition in quiet lakes. Marine soils formed by deposition in seas. Aeolian soils transported and deposited by wind. And colluvial soils formed by movement of soil from its original place by gravity, such as during landslides. Now, why we need to study the mode of transportation and deposition? Because we are interested in the strength, compressibility and hydraulic conductivity of different types of soils. The glacial soils will be having strength, compressibility and hydraulic conductivity different. Alluvial soils will be having strength, compressibility and hydraulic conductivity different. And similarly, lacustrine soils will be having different strength, compressibility and hydraulic conductivity behaviors. Types of soil based upon the texture or the appearance or the feel, we can simply divide based upon the texture into two types. For example, fine grained soils and coarse grained soils. The soils whose properties are influenced mainly by clay and cell size particles are referred to as fine grained soils. Individual particles are not visible by the naked eye. It is divided into silt and clay. Fine grained soils having 50% or more material passing the sieve number 200. It feels smooth, greasy and sticky when touched by hand. On the other hand, coarse grained soils whose properties are influenced mainly by sand and gravel size particles and referred to as coarse grained soils. Individual particles are visible by naked eye. It is divided into two classes, sand and gravel. Coarse grained soils have 50% or less material passing the number 200 sieve, and number 200 sieve opening is 0.075 millimeter. Based upon the USCS system, Unified Soil Classification System, which we will study in our coming lectures. Coarse grain soil feels gritty when touched by hand. So we were talking about the soil classification. Here I would give you a brief review about the soil classification system. MIT soil classification system, they say that the gravels are those particles having size greater than 2 millimeter. US Department of Agriculture, they also say that particles having greater than 2 millimeter size will be classified as gravel. AASHTO classification system and USCS, which is being followed by US Army Corps of Engineers, US Bureau of Reclamation, and American Society for Testing and Materials. So for the agriculture purposes, the USDA system is used. For transportation engineering, transportation engineers follow the AASHTO system, and USCS system is predominantly used by the geotechnical engineers, where they say that gravels are those particles having size greater than 4.75 millimeter and 76.2 millimeters, where the fine particles are those particles having size less than 0.075 millimeter. And as I mentioned earlier on, the soil classification system, the AASHTO classification system and USCS system will be discussed in greater detail in lecture number 6. Now there are various different types of clay minerals present in nature. Particles classified as clay on the basis of their size may not necessarily contain clay minerals. Clays have been defined as those particles which develop plasticity when mixed with a limited amount of water. Now, clay minerals are the characteristic minerals on the earth found near planetary surface, and clay minerals are complex aluminum silicates composed of two basic units, silica tetrahedron and alumina octahedron. Sometimes magnesium replaces the aluminum atoms in the octahedral units. Some of the common clay minerals are kaolinite, elite, and montmorillonite. Now the montmorillonite clay mineral is having a characteristic that if it's there and if it's present in clays, that will give the expansive nature to it. When you add water into that particular soil, it will expand, and when it's dry, when you dry the water content, then it will contract and can significantly affect the compressibility behavior of the clays. So they are commonly found in fine-grained sedimentary rocks such as shale, mudstone, and siltstone. The strength, compressibility, and the hydraulic conductivity also depend upon the geometrical arrangement of individual particles in a soil. Therefore, we must get an idea and we must know the geometrical arrangement of individual particles in a soil, including the geometrical distribution of pore spaces, and that is known as soil fabric. Soil fabric may be used to describe the particle arrangement in both cohesive soils such as silts and clays and granular soils such as sands and gravels. Now there are different types of soil fabric. For example, single grain structure, which is found in sandy or cohesionless soils; honeycomb structure, which is found in silt deposits; flocculated structure, which is found in the case of clay deposits; dispersed structure, which is found in the case of clay deposits; coarse-grained skeleton structure, that is found in the case of composite or mixed soils; cohesive matrix structure in the case of composite soils; Now, the difference between soil structure and soil fabric is that, except that interparticle forces are considered in soil structure. Now, in single grain structure, you can clearly see that if we classify based upon the fabric, it's a loose fabric, whether it's a dense fabric, they are related with the strength, compressibility, and hydraulic conductivity of that particular soil. Honeycomb structure, flocculated structure, dispersed structure, coarse grained skeleton structure, and cohesive matrix structure will be having different strength, different compressibility, and different hydraulic conductivity, which will be discussed in Geotech 2, Geotech 1, and Foundation Engineering. Now, what gives strength to the soil are the soil particles. The behavior of individual soil particles and in their interaction with other particle is influenced by the following forces. For example, weight of the particle and particle surface forces. Now, weight of the particle is the result of gravitational forces and it's a function of the volume of the particle or density of the particle. Particle surface forces are of electric nature. They are caused by the unsatisfied electrical charges in the particle's crystalline structure. Surface forces are directly proportional to the surface area. Now, for large particle sizes, which include soil particles in the coarse fraction greater than 0.075 millimeter, the weight of the particle is predominant over the surface forces. So for coarser soils, this one is predominant, while in case of finer particles, or we can say fine grained soils, particle surface forces are predominant. Now, the water content is defined as the ratio of weight of water to weight of soil. Weight of water to the weight of solids, and if we multiply that with 100, it will give us in percentage water content. Now, the water content of the fine grained soils is generally more than that of the coarse grained soils, and the water content of some of the fine grained soils may be even more than 100%, which indicates that more than 50% of the total mass is that of the water. For example, these are the volume, weight of solids, and this is the weight of water. If weight of water is greater than weight of solids, then the water content will be greater than 100%. And for marine soils, that is predominant case. Now, what is adsorbed water and what is the absorbed water? For example, we are having clay particles. The water which makes a film around the particle This film is known as the adsorbed water, and the water which goes into these pores or the voids, that is known as absorbed water. Now we will solve a short problem. We need to determine the water content within a soil sample as a percentage by drying the soil in the oven at 105 degrees Celsius for 24 hours. The total mass of the soil sample is 30.2 grams, while dry mass of the soil sample is 23.3 grams. So first we will find out the weight of the water. Total mass is this much, while the dry mass of the soil is this much. So this is the weight of water. Now water content is equal to weight of water divided by weight of solids, and this is the weight of solids, and this one is the weight of water. So if we divide 6.9 by 23.3 and we multiply with 100, we will get the water content of 29.6% or approximately 30%. Thank you very much. I hope you are enjoying my videos. Please kindly like, share and subscribe to my YouTube channel. I will be uploading more and more videos related to geotechnical engineering. Thank you very much. Assalamu alaikum and Allah Hafiz.